Hello everyone, welcome back to data visualization tutorial series. In the previous video, we saw how to create bar plots, histograms, scatter plots, box plot, and pie charts. Now, in this video, we will take our data visualization skill to the next level by covering the five additional charts type that will enhance our ability to analyze and present data effectively. So we will also focus on improving the visual appeal of these charts using the formatting techniques such as the color palettes, annotation, and styling. So whether you are a beginner or an aspiring data scientist, this tutorial will help you create more insightful and aesthetically pleasing visualization. So let's get started. So since we have already discussed fundamental charts in the previous video, we will now build upon the knowledge and introduce five advanced visualization. So these charts will provide a deeper insights into our dataset and help us communicate data-driven stories more effectively. So we will be using the same Jupyter notebook and datasets from the first session. Now let's move on to our first advanced chart, the Volley plot. Volley plot is an excellent visualization that combines box plot and a density plot. It helps us understand the distributions of numerical data across different categories while also showing its probability density. So think of a Voronoi plot as an enhanced version of box plot. While box plots provide a summary of data distribution using quartiles, Voronoi plots also show the full distribution shape, making it easier to identify patterns. So in this example, we will visualize the distribution of income across different boroughs. So let's write the code step by step and understand each line. So as we did in the previous charts, we first define the figure size, setting fixed size equals to 12 and 6. Ensure that our chart is large enough to display all boroughs clearly. Now let's create the Volley plot. SNS.Volley plot function. So this function create the Volley plot. Now let's assign boroughs to the x-axis so we can compare different region, and y equals to income represent the income distribution across boroughs. And data equals to specify the data set we are using. Palette equals to cool one. It sets the color theme for the plot and making it visually appealing. So the cool warm palette provide a smooth contrast between the value. Unlike a box plot, the violin plots adds kernel density estimations, which help us see the shape of the data distribution more clearly. So the width of the each section represent the concentration of data points. Wider areas indicate more data, while narrow sections represent fewer data points. Now let's set the title of the plot. We use here font size to ensure the text is large and readable. And we also use here font weight. Set the X label and the Y label name, making the chart more informative. Since borrow names can belong, we rotate the x-axis label by 45 degrees to improve readability. So this is a small but important details when working with the categorical data. And finally, we use a plt.show function to display the plot. Now let's run the code. And here you can see a Volini plot created. A Volini plot that not only show the income distributions across the borrows, but also highlight the density of data points in each category. So this visualization is particularly useful when comparing distributions across the multiple groups, helping us quickly identify patterns and outliers. Now let's move on to our second visualization, the heat map. Heat maps are great for visualizing relationship between the multiple numerical variable in the dataset. So they use colors to represent values, making it easy to identify patterns, correlation, and anomalies. So in this example, we will analyze the correlation between the various economic indicators such as the income, poverty, and the employment. So let's go step by step and understand each line of code. So like before, we set the figure size to ensure that our heat map is clearly visible. 10 and 6 size provide the enough space to display all the correlation without overcrowding. Now here we calculate the correlation between the selected numerical variable in our dataset. And the dot core function compute the pairwise correlation coefficient between the columns, and the resulting core underscore matrix is a table where each value represents the strength and the direction of the relationship between the two variables. And a correlation close to 1 indicate a strong positive relationship, while the correlation close to -1 indicate a strong negative relationship. Now let's create the heat map. SNS.heatmap function. Let's create the heat map using the correlation matrix. And not equals to true. So this ensures that numerical values are displayed inside each cell, making it easier to interpret. And CMap equals to cool warm. So this color scheme helps in differentiate positive and the negative correlation. And line width equals to 0.5. It adds thin white lines between the cells and improving the readability. And then we add a descriptive title to indicate that the heat map represent Formatting options like font size equals to 14 and the font weight equals to bold. Font weight equals to bold. It ensures that the title is clearly visible. And finally, we use a plt.show function to render the plot. Now let's run this code. So this heat map gives us a quick and initiative way to identify correlation between economic factor in our datasets. So for example, if employment and income show a strong positive correlation, it indicates that higher employment level are associated with the higher income. And conversely, a negative correlation between the poverty and the income suggests that income increase and poverty decreases. So this kind of analysis is essential for data-driven decision making. So now let's move on to our third data visualizations, the pair plot. A pair plot is a great way to visualize the relationship between the multiple numerical variables simultaneously. So it creates scatter plots for each pair of variable while displaying their individual distributions along the diagonal. Now in this example, we will compare the employment, income and the poverty level. So let's go through the code step by step. SNS.pairPlot function. This function create a grid of scatter plots to visualize pairwise relationship between the multiple numerical variable. Then we specify here numerical column names. Income, income per capita, poverty, and employed. So it specifies the subset of numerical columns we want to analyze. Then we add here a type underscore kind equals to KDE. It determines the type of plot to use along the diagonal. So here we use kernel density estimations to show the distribution of each individual variable. And lastly, we add here palette equals to cool warm. It set the color theme, making the visualization aesthetically pleasing. So now let's run this code. So here you can see the plot is created. The pair plot allows us to quickly explore the relationship between the multiple variable in a single visualization. So this is especially useful in dealing with the dataset containing the many numerical features. So the diagonal of the pair plot represent the KDE plots of the individual variable, providing insights into their distributions. And the scatter plots in the grid help us understand the relationship between the variable. For example, we can check if higher income is associated with lower poverty, or if employment is positively correlated with income. Now let's move on to our next chart, the stack bar chart. A stack bar chart is useful for comparing the subcategories within a main category. So in this case, we will visualize the distributions of men and the women across different boroughs to better understand gender demographics. So unlike a regular bar chart, a stack bar chart segments each category into a multiple subcategories, making it easier to compare total values while also showing the breakdown which within each category. So as we did in a previous chart, we start by defining the figure size to ensure our visualization is clear and well structured. Now let's write code to prepare the data for stack bar chart. Gender underscore distribution equals to census data dot. Here we use a dot group by a borrow to group a data by borrows. Then sum up the total number of men and women in each borrows. So this help us create a clear comparison of gender distribution across the different region. Now here we plot the stack bar chart gender underscore distribution dot plot. Here we use kind equals to bar, specify that we are creating a bar chart. Then stack equals to true. It ensures that the bar are stacked on top of each other instead of side by side. Now color map equals to validities. It enhances the visual appeal of the chart by applying a smooth color gradient. And then we add here fixed size equals to 12,6. It maintained the consistency with our previous chart by ensuring as well sized figure. Now to improve the readability of our chart, let's add here a title with plt.title function. Then let's add here labeling the axis with plt.x label. And for y-axis plt.y label function. Rotating x-axis labels to avoid overlap using plt.xticks rotation equals to 45. Add legend to indicate gender distribution using plt.legend. Title equals to gender. And finally, we use plt.show function to display our stack bar chart. Now let's run this code. Here you can see the stack bar chart are created. A stack bar chart that provides a clear and the concise breakdown of gender distributions across the borrows. So this visualization help in comparing the gender demographics within each borrows while also giving the overall sense of the total population. Stack bar charts are particularly useful when working with the demographics or categorical data that include the multiple subgroups. Now let's move on to our final visualizations, which is donut chart. A donut chart is a variation of pie chart, but with a hollow center, making it visually more appealing while still effectively displaying the portion. So it is widely used to represent a percentage distribution of categories. So in this example, we will visualize the racial composition in our data sets. So let's go step by step and understand each line of code. So now let's calculate the mean percentage for each racial categories in the data sets. Then add here label list contain the categorical to be displayed. Then add color list. Define a color scheme for better differentiation of categories. Now let's create the donut chart. So let's first add the figure size. Pages, text, auto text equals to. Now let's create the pie chart here. pfd.pie pie function, it create the pie chart. Then race underscore counts, it specify the numerical value corresponding to each category. Then add labels equals to labels, assign the labels to the slices. Then add auto PCT equals to, in a single quotation, percent dot 1f percent. So it display the percentage of each category inside the slices. Now we add here colors equals to colors. It define the color for the segments. Now add here a start angle. Start angle equals to 90. It rotate the chart for a better starting position. Then add here PCT distance equals to 0.85. It adjusts the placement of percentage label within the chart. Now here we add a white circle in the center to create the donut effect. So here we add a white circle in the center to create the donut effect. Then the plt dot circle function is used to overlay in a circle in the middle of pie chart. In here we add a title to clearly indicate what the chart represent. And finally display the chart using the plt dot show function. Now let's run this code. Here you can see the donut chart. So this donut chart that provide the initiative breakdown of the racial distribution in NYC census data. Unlike a traditional pie chart, the hollow center improves the readability and make the visualization more aesthetically appealing. So this type of chart is commonly used in dashboards and the reports for the better data representation. So that's it for today. In this tutorial, we covered some charts, Voronoi plots, heat maps, pair plots, stack bar charts with annotations, and donut charts. So these visualizations provide a deeper insights into our dataset with enhancing readability through styling techniques. I hope this tutorial was helpful. If you have any questions, feel free to ask in the comments. Thank you for watching and see you in the next tutorial.